Hello everyone, I'm Joe and he's Long Yushen and we are both from SMJK Samdet Ipoh. Okay, so today we are going to conduct this experiment, the fireproof balloon.
The topic related to this experiment is heat, and the learning objective is to find out how can we hold a balloon directly to the naked fire without bursting it.
Okay, so the materials needed are 2 round inflated balloons, 1 filled water, this one not filled with water, 2 candles, 2 red top stands, and 2 boxes of matches.
In order to prove that the fireproof balloon works, let's light up the candles now and see what happens next. It burst instantly. Like, look at this, it did not burst at all. And there are some black suits down there.
Yeah, see, there's some black suit. Okay, so why does this happen? Why does the balloon with water not burst directly under the naked flame? Okay, so actually the water inside absorbs most of the heat produced by the flame. And thus the rubber of the balloon does not get very hot, and so it does not weaken, the rubber does not weaken, and it will not burst directly under the naked flame. Okay, so we can prove now here that water is actually a very good absorber of heat. It has a very high specific heat capacity. It actually takes 10 times more the amount of heat to raise 1 gram of water by 1 degree Celsius than it takes to raise 1 gram of iron by 1 degree Celsius. So that's why it takes such a long time for water in the tea kettle to boil. Imagine just 2 liters of water and it takes 10 to 15 minutes to boil. I mean, that's so long, right, compared to our experiments. See the black soot. Okay.
There's more and more black soot appearing from the surface of the balloon.
Yeah, underneath the balloon. Okay, so thank you very much and we'll proceed to our next experiment. Bye!
We'll continue with our science show with the next experiment.
Okay, so the name of the title of this experiment is Rocket 1 is Born. The topic that we are going to touch on is principle of conservation of momentum. Okay, so what's our learning objective? Our learning objective is to demonstrate the principle of conservation of momentum by using a launching object due to chemical reaction.
The principle of conservation of momentum states that the total momentum of a system is constant provided that there is no external force acting on it. So in this experiment, what are the materials we are going to use? Basically, it's a very simple experiment. We have some safety goggles just for our safety, some water, a chewing gum bottle that has a easily open bottle cap, and an Alka-Seltzer tablet. So for our safety, we put on the safety goggles already, and to continue with the experiment, first of all, just open the lid, put the Alka-Seltzer tablet, half of it, into the bottle, and put some water and close it back. But these few steps will be done very quickly. So let's see. So put it upside down and wait for it to react. So you saw it exploded, and Rocket 1 is born and it launched into the sky.
Okay, so what actually happened inside the chewing gum bottle? Okay, so when you add water inside it, it actually starts to dissolve the Alka-Seltzer tablet. When the Alka-Seltzer tablet starts to dissolve, it creates a gas called carbon dioxide gas. As more and more of this gas starts to build up inside, more and more pressure is being accumulated, and finally until the cap cannot withstand the high pressure inside and the cap is blasted off and the rocket is launched. Okay, so when the acid and the sodium bicarbonate inside the Alka-Seltzer is reacted with water, the carbon dioxide gas is accumulated and it launched.
And it forces the cap to open, and therefore the other part of the bottle launched into the air.
Back to our science show. So now we'll proceed with our third experiment.
This experiment is to teach us how to make fake snow. Now, sodium polyacrylate used in this experiment is a type of superabsorbent polymer. Superabsorbent polymers are polymers that can absorb and retain extremely large amount of liquid relative to their own mass.
Okay, so the materials needed for this experiment are actually pretty less. Sodium polyacrylate, beaker, and water in a conical flask. Okay, so what are we going to actually do? First, the sodium polyacrylate is obtained is already placed inside this beaker. And next, all we have to do is just add water into the sodium polyacrylate and we'll see what happens.
Sodium polyacrylate is now turned into a solid and then erupts into a jelly-like gel. You see, it's like really jelly-like gel thing, and it's a snow-like material. It instantly expands up to 50 times of its original volume. So what's the science explanation behind this experiment? Sodium polyacrylate is actually, as stated earlier, a type of superabsorbent polymer and absorbs the water by a process called osmosis. During osmosis, the water molecules pass through the large polymer molecule that is sodium polyacrylate, and therefore causing the sodium polyacrylate polymer to stretch and swell to a very large size. Thank you.
And welcome back to our science show. So now we are going to proceed to our last experiment, which is called the fantastic foamy fountain. The topic we are going to touch on in this experiment is the exothermic heat reaction. So what's the learning objective? Well, the learning objective is that we are going to demonstrate what is exothermic heat reaction through the decomposition of hydrogen peroxide.
Right. First of all, the exothermic reaction is a reaction that releases energy by heat. So the experiment, we'll conduct the experiment by using a few simple materials that you can get in the lab: dishwashing liquid, flat bottom flask, food coloring. We're using red this time, and this is potassium iodide solution, hydrogen peroxide 30% concentration, some safety goggles for us, and yeah. Alright, so first of all, we have put on our safety goggles as usual, and now we will pour some hydrogen peroxide 30% concentration into a flat bottom flask. Alright, please be careful.
Sure.
And after that, we will put some food coloring. We are using red. Okay, and we will just stir it for a while, make it even. Right, so after that, we will add some dishwashing liquid.
Yeah, squirt will do. Okay, that's done.
And the final one, the potassium iodide solution. So I'll put this here. I'll pour the potassium iodide solution into the flat bottom flask, and we just back off for a while. Right. So let's see the reaction. Right, this our foamy geyser. Okay, you can see some steam coming out.
Yeah, that's the exothermic heat reaction happening. This is actually heat.
And at this time, the flask is hot because it releases heat. Right, what happens is that the foam produced, right, all this foam produced is special in a way that each and every tiny little foam bubble is filled with oxygen. You see, it's filled with oxygen. Of course, you can't see it now, but it's filled with oxygen. And the potassium iodide acts as a catalyst to remove the oxygen from the hydrogen peroxide. Since the reaction is very quick, so lots and lots of bubbles are produced during the reaction.
Okay, so this experiment shows the catalyzed decomposition of hydrogen peroxide into water and oxygen gas. But normally, without a catalyst, this experiment is too slow to be easily perceived or measured. But then, the iodide ion inside the potassium iodide solution acts as a catalyst for this decomposition of hydrogen peroxide. So the reaction is quicker, very quick. And just now you can see the steam emanating from the foam is actually the exothermic heat reaction happening because it is releasing heat in the form of steam.
The basin now is also quite hot, and I feel it, the basin is quite hot, and there's still some steam coming up from the foam.
And the round bottom flask too. Okay, so that's the end of our final experiment.
Right.
And
thank you very much, and I hope that you guys enjoy the show.
okay, bye.